will see Manchester encoding. In Manchester encoding, clock interval is divided into two parts like this. Here this is signal formation, wherein this clock interval is divided into two parts. So this is first half of clock interval and this is next half. Voltage values used to represent binary bits are high, low and 0. So three voltage levels are used. To represent bit 0, high-low combination of voltage levels is used. Means initial part or first part of clock interval is high and second part of clock interval is low. So this is high voltage level, 0, low. To represent bit 0, first interval or first half of the clock interval is high and second is low. So high and then low. So in this particular clock interval, first half is high and next is low to represent bit 0. To represent bit 1, low-high combination of voltage levels is used in a single clock interval. So initial half of clock interval is low and second half is high. So low and then high. So this is digital signal for bit 0 and this is for bit 1 in Manchester encoding. Now using this representation for bits 0 and 1, we will encode example bit string in Manchester encoding format. Now we will see Manchester encoding for this given bit string. Here voltage levels used are high, 0 and low. Bit 0 is represented by high-low combination and bit 1 is denoted by means of low-high. These two representations are as per IEEE 802.3 standards. So let us encode this given string. Here each clock interval is divided into two parts and for each bit one clock interval is required. So this clock interval is for initial bit 1, 0 and so on. Now first bit is 1. 1 is represented as low initially and then high. So for this bit, initially low and then high. Second bit is 0. For 0, high, low. Next 1. So low and high. 0, high, low. Again 0, high, low. Then 1, low, high. Here we need to connect this for signal continuation. Again 1, low, high, connect this and 0, high, low. So for this bit string, Manchester encoding digital signal is like this. We'll solve one more example for bit string 10110100. So here also one clock interval per bit which is divided into two parts, 1 0 1 1 0 1 0 0. To represent it in Manchester encoding, 0 is represented as high low and 1 is low high as per IEEE 802.3 standard. So first bit is 1 here, so low, high. Second bit is 0, high, low, 1, 1, low, high. Continue, connect this. 0, 1, 0, 0. Connect this. So for this second example, Manchester encoded digital signal is this.